Hi children, good morning. So I think we are going to begin with our live class now. So what is the plan? The first set, today I am taking a common paper and I will be solving most of the sums with your help, or you can also take the initiative in solving those questions. This Prelim paper is specifically only for ISC board students for class 12. Secondly, I want to share with you something very important. Okay, what is important is I want you to understand how many are present. So please give a thumbs up there. I want to see how many are present there. So are you all ready to start with the class? So some questions I will be solving, some questions I will be putting in your court to solve it, and we will see how we go about it. So in between there will be a 5-minute break. If you had not subscribed to the channel, please subscribe to the channel so that whatever videos I am uploading it, you are able to access it at your own convenience. Okay children, good morning once again all of you. Let us begin with the class, but before that I just want a thumbs up from all of you. How many are live? Can you just put a thumbs up that you are all ready? So 2 minutes I give you for that. Okay, let us begin with the class now. So here we go, because instead of just waiting for others, let us move ahead with the class now. Now there are many questions we will be taking, but this is exactly the 1 mark and 2 mark questions will be there on the board, in the board paper. So I want to just assure you that whatever sums possible I will work on that, okay, in the best possible way. Okay, now here we go. The first question comes up, proving that sine inverse 63 by 65 plus sine inverse 5 by 13 plus cos inverse 3 by 5. Now what you understand from your children, very important. First point which I want to share with you is, you have to prove. So RHS, you can apply sine inverse x plus sine inverse y, cos inverse x plus cos inverse y. Or better, as this is in terms of sine inverse, the best bet would be getting this into terms of sine inverse, or you can get into tan inverse also, so that in the end you can convert this into tan inverse. Okay, so let us begin now. I think this sum most of you could do it. So just to start with this lecture now. So first thing, whenever you want to convert any ratio into the other trigonometric ratio, my suggestion is draw a right angle triangle and see what happens. So if I draw a right angle triangle here, so I am talking about RHS now in this case. So in the RHS part, I am just drawing a right angle triangle here. Okay, this is sine ratio, so 5, 13, I think this should be 12, right? Similarly for this also, why I am doing this? So that I can get a comfortable inverse ratio. Specifically tan is always my preference, because applying the formula for tan inverse x plus tan inverse y becomes simpler. So cos inverse, this is 3, this is 5, and this is 4. So what I am going to do, I am working on the RHS now, I am converting into tan inverse, or you can convert this into sine inverse and do sine inverse x plus sine inverse y. Okay, that also you can do that. So what I will do is sine inverse 5 by 13, please understand, plus sine inverse, what happened, try to understand this, sine inverse, what will happen, 4 upon 5. This is the angle which I am considering. Please pay attention now. Once you finish with this, I think sine inverse x plus sine inverse y, you can use the formula. So what is the formula for sine inverse x plus sine inverse y? it is sine inverse x root 1 minus y square, this is my y, 16 upon 25 plus, what are plus y root 1 minus x square, 1 minus 25 upon 169. Now I think if you simplify this, it will be a better game changer for all of us. So this will become sine inverse 25 minus 16 is 9. So you can say this is 5 by 13 into 9 by 25. Remember, this square root allows full square root it is. So 9 minus 16 will be 3 by 5 plus 4 upon 5 into, now 169 minus 25 is 144. So square root of 144 upon 169. Remember, the 116 is also inside the square root sign. So 144, this is nothing but 12 upon 13. So I don't have to do much cancellation in this, even though you can cancel this, because if you look at the denominator, it is 5 into 13, 5 into 13. So keep it as it is. So this will eventually will be sine inverse. Try to understand what happens here. 5 3s are 15 plus 48, that is 63 upon 65. So this is nothing but my LHS. You can have a look here, 63 upon 65. So you can either convert this into tan inverse, apply tan inverse x plus tan inverse y, and you can get back to the sine ratio by using the right angle triangle. This is a very important part of the concept there, where you can convert any trigonometric ratio into any other trigonometric ratio subject to use the right angle triangle format. Okay, so keep that in mind. So this is what you have to prove. So first type in inverse is nothing but proving question. So this can come for 2 marks, okay, or it can come for 1 mark also, but 2 marks would be preference for this. Let us take the next question now. The next question, I think it's matrices there, so you have to be very careful. It's not determinant, is matrices. So remember, it's one element there. These are not 4 elements there. So x plus y is equal to, there is some error here, because no error, because there is an equality multiplication of these 2 matrices. So first thing you have to multiply these 2 matrices and see what happens. So let us see. So this will become x plus y as it is, because the right hand side has to be, you have to work out the multiplication on your own. So what is the multiplication? Row into column. So 2 minus 2 will be 0, then 4 minus 6 is minus 2. I hope it's very clear how you multiply 2 matrices. Once you finish with the equality there, left hand side 1 matrix, right hand side 1 matrix, you have to just go and equate it. So x plus y is equal to 0 and x minus y is equals to minus 2. Now what you understand from here? Solving, nothing else. So 2x equals to minus 2, where x equals to minus 1, and what happens to eventually, if x equals to minus 1, then y will be equal to 1 just by substituting in any working. So I hope you got this point clear, children. The first simple sums, inverse ratio. Remember, this is exactly the standard for the board, standard of the ISC board to put up the questions for 1 or 2 mark section. So I hope you got this point clear. So this is the way you deal with the question, this is the way you format the question, this is the way you really ponder upon the solution of this particular thing. So I hope you got this point clear, children. You are very careful and catchy. Okay, so just pen it down quickly and then you'll come to know exactly what is the next question. So I'm going to give you not more than 2 minutes for doing this, but don't take a snap. The more you work on your own, the more you will really get the confidence in this paper. Okay, so please note it down. Done, children? So let us take the next question now. The next question comes up with full flow. Now this is a specific 1 mark question here which I am showing you on the screen, and of course this is also 1 mark question. Now if you look at the first question there, they are telling show that the function f n to n, remember here n to n, it doesn't mean it means natural numbers to natural number, given by f of 1 is 2, f of 1 is 1, f of 2 is 2, and fx, the function is defined as x minus 1 for every x greater than 2. So x value has to be greater than 2. So is on 2 but not 1 1. Now this is something very important, is not 1 1. Now if I talk about 1 1, I'll just share with you. Okay, I'll just share with you. If I say about 1 1, okay, remember you have to prove it is not 1 1. Okay, so be careful, simple it is. Now not a 1 1. So remember this part, f of 1 is 1 and f of 2 is 1. That means when x is equal to 1, f of 1 is 1, right, f of x. When x is equals to 2, f of 2, so f of 2 is also 1. So what does this mean in this? That when the input is 1 2, you are getting the same image 1 1. So when I put x equals to 1 in the function, I am getting 1. When I put x 2 as the x equals to 2, I am getting 1. So you know what is the point which I want to share is, in this case, okay, of course that this definition is something different there, but I have to focus on what is given to me, that is important for me. So this becomes many one function, so therefore I can say the function is many one. So sometimes what happens is, just by looking also you can get the solution. So it is not 1 1. Now when I talk about onto, I told you many times that whenever you want to prove that it is onto or not onto, the first step will be, whatever function is given to you, be careful, you have to write this is y in terms of x, write x in terms of y, whether it's a 1 mark question, 2 marks question, or 4 marks question, or 6 marks question. So what I do with this, so fx equals to x minus 1. So what I do is, so I'll write y is equal to x minus 1. Understand? So what I said, whenever you have to prove onto or not to prove onto whatever stuff, first step is write x in terms of y. So x is equal to y plus 1. Now they are clearly specified, x is greater than 2. So x is greater than 2 matlab, if I put y as 1, 1 plus 1 will be 2. So x is greater than 2. So here in this case surely y is greater than 1. So whatever substitution you put, you have to put a y value greater than 1. Now understand this portion. For onto, this really helps you a lot. This is my x and this is my y. So I ask you a simple question. If I substitute y as greater than 1, now remember y is nothing but a natural number. So if I substitute y as a natural number, tell me what you are going to get x as. If I substitute any natural number greater than 1, what x is going to come? Natural number. So when y belongs to natural number, of course it is greater than 1. Why? Because if I put 1 there, if I put 1 in this, then it will be 1 plus 1 2. But here x value has to be greater than 2. So that's why I cannot take 1. So all the other natural numbers you can take. So if I put y as a natural number greater than 1, my x will be also a natural number. Think properly. Y is a natural number. Natural number plus natural number will give you a natural number. And does it satisfy? Yes, this satisfies. See, when I put y as a natural number, I am getting x as a natural number. So what does that mean? It means that all images in y are some element in x, some pairing item in x. So that's the reason I can say that function is onto. It's not difficult, I want to just have a look at this. Okay, got the point clear? The next question comes up here. They are telling write a differential equation. Okay, now this is something, instead of sometime saying that write, they can also say form. Form a differential equation. Okay, form a differential equation for y is equal to a cos alpha x plus b sin alpha x, where a and b are arbitrary constants. Now remember, I have to form a differential equation. How I form the differential equation? By taking the derivative. Because what is a differential equation? The derivative has to be there in the place. So the question is, how many times I take the derivative? You have to take the number of times the derivative, the number of constants are present in this. So here then a and b are two constants, a and b are two constants, that means twice you have to take the derivative. So if I want to say, so they had given here, please understand this. So y is equal to a cos alpha x plus b sin alpha x, right? Okay. Now when I say y is equal to a cos alpha x plus b sin alpha x, so first derivative comes up, minus a alpha sin alpha x, right, minus a sin alpha x. How I got this? A is a number there, then cos alpha x is minus sin alpha x, and by chain rule alpha x derivative is alpha, then plus b alpha cos alpha x. Now I told you how many times you will take the derivative. You will take that number of times the derivative as the number of constants. Remember, you are forming a differential equation, not solving. Forming means the dy by dx has to come into the place. So I take it further now. So I take it further. So two constants, one derivative is over. Once again you have to take the derivative there. So this will become d square y by dx square. Again you have to take the derivative of this. So it's not difficult, you have to be very careful. Now look at this. Minus a alpha. Okay. So this will become what? Sin alpha is cos alpha x. So cos alpha x into alpha. So what will happen? This will become minus alpha a square, alpha square a minus alpha square a cos alpha x, cos alpha x plus cos alpha x is minus sin alpha x. So minus, you can say minus, it is b alpha square sin alpha, b alpha square sin alpha. That might get cut there. Now very simple, take alpha square common in this case. So if I say d square y by dx square, and if I take minus alpha square common, now what remains? Let us see, a cos alpha x plus b sin alpha x. Okay, just got cut there, I am sorry. But what is this a cos alpha x plus b sin alpha x? It is nothing but y. So eventually d square y by dx square will be what? Minus alpha square y. This simplification is the key. Remember, in this function has to be replaced by something else. I mean to say in the final answer. So this is my differential equation. So by the way, let me just make it more simpler. Whenever they ask you form a differential equation, you take derivative. How many times you take the derivative, it all depends upon the number of constants which is given in the function. So number of constants is 2 here, so twice derivative. So this is the final output of the differential equation. In some cases, rare cases, there is no question of simplifying this or substituting this because it doesn't match up sometimes. But in 99% cases you will find this situation where you can simplify and shrink it to a notable format. So the first one is proving onto and not 1-1. I hope the procedure I am making it clear. And the second case, please understand, this is 1 mark question. So 1 mark question, you need to be very, very precise and short explanation. You don't have to write a full pages of work. I hope you got this point clear. And forming a differential equation is also 1 mark, because I have a definite feeling that in the board exam they might catch up with this particular part also. Okay, so pause and note it down. I give you 2 minutes for this particular work. Can quickly take it down. Next question comes up now. Right, now these sums are really good sums. 2 marks question is the storage for that now is stored for this particular question, 2 marks question. Now let us take the first question so that you understand what we are doing. That in probability of E union F is whatever stuff they had given to us, there is no issue at all. Now twice of P is equal to 5 by 13, PF for probability of F event is 5 by 13. This is a clue. P of E by F is given to you, right? Now everybody knows first point, I am just going to write this out. P of E by F is what? P of E intersection F upon P of F. I think it's very simple. Now you might ask me, so what you are finding? You have to find P E union F, and what you are doing? Now if you remember the main formula which we had seen in P of E union F, I would not say P of E or F, is nothing but P of E plus P of F minus P of E and F. Now this formula I think I am presuming that you all know, but what is important is, remember, these sums are to be done with this method only, this formula only. Now if you look at this E union F, they are asking us, I know P of E, that is 5 by 26 because 2 goes down. P of F is given 5 by 13, and P of E by F I don't know, P of E intersection F I don't know. So using this P of E by F, I have to find the P of E intersection F. So E by F is given as 2 by 5. So let me just see what comes up. This is 2 upon 5 is equal to P of E intersection F upon P of F. Now what is P of F equals to 5 by 13? 5 by 13. So you can try it out now on your own and see what is the working you are getting. Please try it out. Okay, check it out and tell me once you get the P of E intersection F, you can get. There is some error here. 1 second, I will just find out that error. 1 minute, let me just check the sum. Okay, fine, I think you can work out. So I think this goes down here. So 2 by 5 into 5 by 13 is equal to, right, it is P of E intersection F. I can cancel this out. So this is nothing but 2 by 13. Put it across. So P of E, what is P of E? P of E is what? 2 goes down. So 5 by 26 plus P of F is already given to you 5 by 13 minus P of E intersection F. Now E intersection F is nothing but 2 by 13. I think it's the best way to do the simplification there. LCM is 26. So this is 5 plus 10 minus 13 2's minus 4. Right. So 5 plus 10 15 minus 4 is 11 by 26. Is nothing but P of E or F. So understand this portion part, because whenever these sums are favorite for 1 or 2 marks on probabilities, not word problems. Okay, so please understand this is the same mechanism, because this is the first theorem on probability what you have studied in class 12 before the conditional probability. So I hope you got this point clear. This is the pattern, this is the way you go ahead with the solution of the questions. Okay, now next question is something very important, integration. So whenever you have integration, you feel something very different outlook towards integration topic. It's not that. You should remember the forms. I had already processed what is chart A, right? What a chart A, the long division comes up, the first category. Second is nothing but integration by substitution and fx upon f dash x, right? F dash x upon fx or fx into f dash x. You use substitution technique. Then we did UV. In UV, you saw integration by parts, general, inverse and log alone. You do into one and then you process the integration by UV method. Third was Ex fx plus f dash x and Ex sin x format. So these are the standard form. So whenever in any integration, when you see e raised to x format of function, your first job is to find whether it belongs to e raised to x sin x cos x or e raised to x fx plus f dash x format or not. So that's the first thing you have to understand. Now e raised to 2x is there. Normally my format was e raised to x, fx plus f dash x. Now what I am going to do is, I will just make it more simpler. I will tell you how. I will say let 2x be t. Without doing that also you can do that. So what will happen now? This will become x dx will be dt by 2. I think very simple. I am taking the derivative. So are you sure x dx is equal to dt by 2? I really don't know. No, because the derivative here, this will go off. So dx will be 2 dx will be dt. So dx will be dt by 2. Now once I think you are done with this, I think I am working on this. So dx, just see what I am doing. Integral dx is dt by 2. So 1 by 2, keep it outside, dt. Now I want to pay attention now. So this is e raised to t. And look what is happening here. This is t minus 5 upon t minus 3 whole cube. Okay, right? Okay, I am just judging out, okay, because it's not necessarily the compulsory part. Now, one second, I just want to show you something. Now, the point is I told you, now you have to always check whether it is Ex fx plus f dash x format. Dx, right? Whenever you have e raised to x. So now there is a problem in this case, because here it is t minus 5, t minus 3. So I just work something simpler for you. Integral e raised to t. Can I write this t minus 5 as t minus 3 minus 2 upon t minus 3 whole cube dt. My work got over. I can give this to both of them and your job is over. If you want to check, you can check it. I have no issue. So 1 by 2 integral e raised to t. See what is happening. This upon this is 1 upon t minus 3 whole square, cancel up, minus 2 upon t minus 3 cube. My job is over, because children, this becomes fx and this becomes f dash x. You want to check it, you can check it out, because I have no issue. This becomes fx, this becomes f dash x. So let us see. 1 upon t minus 3 derivative is minus 1 upon t minus 3 whole square. So it is before, into twice of t minus 3. So 1 t minus 3 cancels. So minus 2 upon t minus 3 cube. So try to understand. So this is my fx and this is my f dash x. Now tell me, when it is integral Ex fx plus f dash x format, what is the answer? The answer is e raised to x fx plus c. I hope you got this point clear. So khatam, answer is e raised to t fx plus 3. So this will become half e raised to t, fx is 1 upon t minus 3 whole square plus c. Don't stop here because you have to replace t by 2x. This is important. You have to replace t by 2x. So e raised to 2x, 2x minus 3 whole square, 1 upon 2. That's the final answer, the solution. So I hope you got this message clear, children. These two sums are really good sums as far as my counter check is concerned on this. So this is the way, this is the pattern by which you have to really process the sum out. So I hope you got this point clear. So pause and note it down. Specifically these two sums, I want to make a note of it, or in fact you can try. Let me give you 2-3 minutes for that. Okay, take it out quickly and then we will go ahead with the next question. Pause and note it down. Come on, quickly take it down, children. Okay, the next question coming up now to all of us. This is a really good sum. Try to understand that point. Now, these two sums, I really prefer that it should come for 4 marks, but they are given for 2 marks. So, it's a very unfortunate thing. But anyway, it's a good question now. How we do it, let us see this proportion clearly. Now, I'll just bifurcate this part first. Okay, now here we go. Now, in this case, that is evaluate 0 to pi by 4. So, it's a definite part of it, but integration I don't have any clue. Okay, such sums are very rare where you don't get a clue for the way of integrating the function. Very few. So, let us see how we go about it. So, in this case, you know, I have only hint is sine 2x. I am just making my work simpler. Please pay attention. Suppose 0 to pi by 4 happens to be there. So, 1 upon cos cube x. Can I write this as 4 sin x cos x? Because you know why? The reason is Sin 2x can be written as 2 sin x cos x. So 2 sin x cos x into 2 will become 4 sin x cos x, right? Now you must say what you did, we are not getting the point. Now remember, sin and cos, the substitution can work on sin and cos, but there is nothing in the numerator to substitute or denominator to substitute, the numerator gets adjusted, something like that. So you have to be a little bit careful about all this work. Now as I said, this is the exclusive sum. I really wanted it for 4 marks. I am making some adjustment. Okay, what I am doing is, this is a root sign. Okay, this is a root sign. So I am dividing by cos square x. Wait, I will just tell you what I am trying to do. I am dividing by cos square x. So what happens now? Cos x and 1 cos x gets cancelled in this case. I am dividing by cos square and I will multiply by cos x, correct? Because it is nothing but inside the root. What eventually happens, it will be 0 to pi by 4. You might ask me, so why you did this? I will come to that point once the idea is clear. So this will become 1 upon cos 4x. That you understand? And in this what happens? Let us see. Now see, 1 cos x got cancelled with cos x. So 4 tan x dx. Now you must say, what is working in your mind? You are not getting the point. I will tell you. Tan x derivative is sec square x, correct? Now 1 upon cos is sec. So that's the point. I just make my work easier now. So this will be 0 to pi by 4. 0 to pi by 4. This 1 upon cos, this you can write as sec square x dx upon this you can write 1 upon 2 outside, and this is root of tan x. My job is over. Okay, I will take this up portion now. So if I say, see, derivative of tan x is sec square x, correct? So if I say let root of tan x be t, so what will happen? 1 upon 2 root tan x into sec square x dx will be dt. So what is getting adjusted? If you understand this, see, 1 upon this 2 is already there. So 1 upon 2 root tan x sec square x dx completely got adjusted. It became dt. So this portion along with this 2 got adjusted fully. So it becomes dt. So what happens here? Wait, I am not changing the limit. Integral. Please pay attention now. So sec square x 1 upon 2 sec square x root tan x dx is dt. So I wrote dt here. Hold on. Now please understand, when dt comes, this sec square x is actually 1 plus tan square x, right? So tell me, now I just come to this, see this. Okay, now what I am going to do is, I just working out and then I will rub it off. Okay, so you know it is 1 plus tan square x. That's it. I had gone to that point clear. Now limit I will do it, but this is wrong presentation, because once dt comes, x has to be replaced by this thing. So come to a substitution. So tan x will be t square, and I want tan square x, because tan square x will be t4. So best would be, what I am going to do now is, I am going to cut this off. Pay attention, this was 1 plus t4. 1 plus t4. Why? Because sec square x is nothing but 1 plus tan square x, and what is tan square x? t4. And now I am comfortable because all variables are in terms of t along with dt. Fine, now I can integrate with respect to t. But now the limit has to change. Why? Because, why the limit has to change? The reason is, in terms of t, this is the limit is for x, not for t. Very simple to change, and I suggest from my experiences, you change the limit once t comes in the picture. Very simple. So look at this, when x is 0. So when x is 0, tan 0 is 0, so t value will be 0. X is pi by 4, tan pi by 4 is 1, t value is 1. So now my job is over. If you look at this, this is nothing but t plus t raised to 5 upon 5 from 0 to 1. So what will happen now? 1 plus 1, right? So 1 plus 1, so 5 plus 1, 6 upon 5 will be the answer. So understand this pattern. This is something very different. Okay. Now this portion is based on axiomatic approach, but anyway, I have to have a clue there. I hope you got this point clear. Understand this sum, how we are processing this sum. These two sums, I really feel they should come for 4 marks, but it is for 2 marks question. Okay, but worth understanding and doing that. Such sums are very rare where you have to do some adjustment. Otherwise, most of the sums you get a clear cut view how to integrate that particular function. Okay, right. Now come here. Now look at the probability question. The probability question is something very different there. Pay attention. A die is thrown 3 times. Events E and F are defined as follows. E is equal to 4 on the third row and F is 6 on the first and 5 on the second row. Find the probability of E given that F is already occurred. Matlab, they are asking you E is given, find probability of F by E. That's what they are asking. So, sorry, find the probability of E given that F has already occurred. So, by the way, please understand conditional probability. What is given to you in this case? Find probability of E by F, which is already occurred. Now everybody knows P of E by F is P of E intersection F upon P of F. So if you know these two values, that is not E, by the way, this is F actually. So please pay attention now. Now let us see this proportion here. A die is thrown 3 times. Now remember, in this case it's just not possible. See, when die is thrown twice, you can say 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6 and so on. But when I say a die is thrown 3 times, how you write the sample space? So the sample space, if this is one die, now this is axiomatic approach. If you remember, this is one die and the third die, because it is thrown 3 times. Please understand this. So total outcome 6, total outcome 6, total outcome. So 6 into 6 into 6 is nothing but 216. So total sample space will be 216. So I am agreed for this particular experiment. Great. Now suppose they are telling us E is 4 on the third row. So E, I am talking about the probability of E. Hold on. Total outcome is 216. 4 on the third row. So if this dies 1, 2, 3, this 4 on the third row, 4 on the third row. So 4 is fixed. So total outcome will be 6 into 6, 36. This is 1. 4 is fixed. So 2 dice variation will happen in 2 dice, 1 2, 1 3, 1 4, 1 5, 1 6, 4. 4 is fixed. So it is 36, this 6 outcome, 6 outcome. So 6 into 6. So this is nothing but 36 upon 216. F outcome says, pay attention, F outcome says, this is called axiomatic approach where we are doing directly. So pay attention, very nice question. 6 on the first, so 6 is fixed, lock. 5 on the second, 5 on the second. So these two numbers on the first 2 dice is fixed, that is 6 on the first and 5 on the second. So this is fixed, and in this case there are 6 outcomes are there, correct? Last die can become 1, 2, 3, 4, 5, 6. So that's what. So what happens now? This is 1, so 6 outcomes. So 6 outcomes. So it is nothing but there are 6 outcomes. So 1 into 6. So 1 into 1 into 6. So what happens, because this is into 1 you can, because only one outcome is there, 6, 5 fixed up. So 6. So 6 upon 216. Now hold on. There is some problem. What is the problem? I will tell you. So I got P of F, I have no issue. Now I need to get P of E intersection F. Now E and F, it means E and F. So E and F matlab kya? Now look, what is E? What is E? There is a die. So P of E and F. So dice is here, dice is here, dice is here, right? Now then what is E? E is 4 on the first dice. 6 is 4 on the third, sorry, 4 on the third, fixed. 6 and 5. So 6 on the first and 5 on the second. How many outcomes you are having? Only one. Because 3 dice are there, 4 is a number which is fixed on the third die. And what is F? Because it is E and F. F is nothing but 6 on the first die. The number 6 will be there on the first die and the second die, so 5. So how many outcomes? So it is a simple outcome, that is 6, 5, 4. 6 number, 5 number and 4 number. So 6, 5, 4. So E intersection is nothing but 1 upon 216. Finish. My job is over. I hope it is over. So what happens now? I got already 6 upon 2. So here we don't need this actually. There is no issue. So what happens is P of E intersection F. Sorry, we are asking P of E by F. E by F is nothing but P of E intersection F is 1 by 216 upon 6 upon 216. 6 upon 216. So it is 1 upon 6. So it's not difficult, children. Today really we are doing very good questions. I wish that everybody understands it properly. So this is, we are using axiomatic approach. Axiomatic approach, because in this case 3 dice, 206 outcomes, how you are going to write? It is just not possible. So I hope you got this point clear, children. The total number of outcome is 666, total sample space. So you can say this is sample space for your just reference. Okay, nice question. So please space it out and copy it down. I give you 2 to 3 minutes for this particular point. So please do that quickly. Take it down quickly. Right, so I hope you got these two sums very clearly. This is what is required for at your end. This part is very, very important. Remember, throwing 3 times the dice, 6 into 6 into 6, that is 216. So that's what it has to come. Okay, keep that in mind. Quickly take it down. Two sums are the favorite there. Take it down quickly, children. This is something very interesting. The next question coming up. I want to focus on this question there because this is something important. Okay, let us go to the next question now. Are you done, children? Akrant, you finished? Okay, next question coming up. Now, this is something very important. I want to say this was a favorite in the board exam. It has come twice in the board paper. Differentiate. It looks simple, but it's not as simple as I mean. From here onwards, we are starting with the 4 mark section. So I just wanted to have a first-hand experience on this particular sums. Okay. Now, how we do it, everything I'll just focus on that for you all. So please pay attention now very carefully. Now, if I say, remember they are in differentiate this with respect to this function raised to function. So when function raised to function, what is the procedure you adopt? You adopt log on both the sides. So that is, you have to keep in mind log on both the sides. I do that. So here let us see. So if I put let y be equal to x raised to x. Now what I can do is I can take the log on both the sides and then see what happens. So log of y is equal to log of x raised to x. Now please understand there is a difference there now. So once you take log, this is called logarithmic differentiation if you remember. Both sides when you take log, so log m raised to n, apply the properties of logarithm. So if I apply the properties of logarithm, what is going to happen? Log of y is equal to n log m. So x raised to x log of x. So eventually what I am going to do now? I am going to do u and v rule. So what happens when I do u by v? U and v, u into v rule, right? Product rule. So 1 by y dy by dx u derivative of v. Purposely I am writing this, why I will tell you, plus v derivative of u. Now I have no issue with this. Derivative of log x is 1 by x, log x as it is derivative of x raised to x. So again function raised to function. So better would be you solve that derivative separately. You can say let u be is equal to x raised to x. Don't confuse. I said y is equal to x raised to x raised to x. But as I need to find the derivative of this, I will find the derivative separate and take this and place it here. It is as simple as that thing. I hope you got this pretty clear. So again function raised to function, take log on both the sides. So log of u is equal to log of x raised to x. So again apply the property there, log m raised to n, bring the n down. So log of u is equal to x log x, right? Okay, I am done. So log of something, what is derivative of log of something? 1 upon u du by dx is equal to, again uv, u derivative of v is upon x plus v derivative of x is 1. So eventually du by dx, u cross multiply, so this is x raised to x into 1 plus log x. So I already got a derivative of u. So now I think I can place my answers here. So this is 1 by y dy by dx is equal to, so x raised to x upon x, you can make this x minus 1, no problem, plus log x, this portion I already just now found the derivative there, so this is nothing but x raised to x 1 plus log x. That's it. I think that's the way you go. If you want, you can write x raised to x common and then solve this out, or you can write x raised to minus 1 plus x raised to x log x. But wait, this y has to be taken back. So dy by dx is equal to x raised to x raised to x, because this is my y. This is my y. And then everything will come like this: x raised to x minus 1, same base, plus x raised to x, I am just rearranging this, log x 1 plus log x. So this is my solution, complete solution for the derivative. So 4 marks question. Remember children, function raised to function is going to be the key in all this particular sum. Okay, in this type I will say function. So what has happened, where you did log, then in log after taking log again you took log and you solved it, because this part I want to find the derivative very exclusively. So I hope you got this point. So remember the variation in the board paper. That's the point which you have to keep in mind and how to go about that. Okay, so can you place yourself in a better position? And the next 4 mark question is coming up. I give you 2 minutes to copy this question quickly and sharply. Take it down quickly, the nice question. Next 4 mark question is coming up. Take it down properly. This question I want you to take it down because it's worth noting it down. ஹலோ இப்போ நான் கிளாஸ் நடக்கிறது நான் இப்போ வீடியோவில் இது லைவ் லெக்சரில் இருக்கிறது நீ ஃபோன் பண்ணி சாப்பிடுவேனா இல்லையான்னு அதெல்லாம் யோசிச்சுட்டு இருக்கேன். வருவேன். Next question, 4 marks question coming up on the screen now. Now this is there are many ways to do this question, there is no problem at all. Okay, so let me see the way I want to go. So first thing is there is solve. Now when I say solve in inverse ratio is the 4 mark question. Okay, solve, that means you have to find the value of x. Be careful, if I take cos inverse I can take that side, so this is a standard angle, that's why I can do that. So this will be sine of cos inverse x is equal to, cos inverse goes that side, this is cos of pi by 3, cos 60. Cos 60, what is cos 60? Cos 60 is 1 by 2. So what I can do is, this has become sine of cos inverse x is equal to cos 60 is nothing but 1 by 2. I hope That's right. Okay, that's fine. Now something very important now I just want to mention. You can take sine this side, so it becomes sine inverse half. But the problem comes, because it is a cos inverse. Now then you take cos, you get only one value for such sums. You have to just ensure that the second value is not neglected at the minus number. So what I do is I convert this into sine. So if I use the right angle triangle, this is x upon 1, cos ratio, this is x1, this is 1 minus x square. You have to be careful this. So I will convert this into sine inverse because sine and sine inverse are compatible. So this will become sine of, this is sine inverse root of 1 minus x square is equal to 1 by 2. Now my job is something simple. Sine of sine becomes compatible. So this is 1 minus x square is equal to 1 by 4. So x square is equal to 9 by 4. So x equals to, I hope I am getting this, no, 1 minus 3 by 4, 3 by 4. So x equals to plus or minus root 3 upon 2. Now you might ask me, so why I did this? Can I take sine that side? You can take, but you will get only one answer plus root 3 by 2. But in some questions you get a dual answer. Keep that in mind. Okay, so what my suggestion is, the end part you work out with the simplification skill. Once you do this, you have to decide whether you have to accept both the answers or not. So x equals to plus root 3 by 2, x equals to minus root 3 by 2. Substitute this, each one in this, and see whether you are getting the same answer, that is pi by 3. Whichever value satisfies, that will be a solution. In some sums only one value satisfies, in some sums both the values satisfy this particular equation. So I want you to really have a look at this. I think it's both are satisfying, okay, because cos inverse root 3 by 2. Now root 3 by 2 is nothing but what? Pi by 6, that is 30. So this is sine 30. Sine 30 is nothing but, sine 30 is 1 by 2. Now cos inverse 1 by 2 is pi by 3. That's true. Similarly here also minus. So cos inverse of minus is cos only, right? So sine of same thing, root 3 by 2, that is pi by 6. Cos inverse of pi by 6, that is pi by 6 becomes sine of pi by 6 is nothing but 1 by 2. So cos inverse of 1 by 2 is nothing but pi by 3, root 3 by 2. So working is to be same, both the values are satisfying this particular inequality, the equation here. So I think in this case the solution is x equals to plus or minus root 3 upon 2. 4 mark question, chunk of it, please take it down. Let us wait for the next question now. It's coming up on the screen. Are you done, children? Be careful, you can't play spoil sports here. Both the values you need to substitute and find which is the, sometime many sum one of the values satisfies, in some both the values satisfy. So don't ignore this, you might end up losing 1 mark or half mark depending upon the total weightage. So my job, 4 marks question, this I am giving a weightage to this particular sum. So understand what we have done till now. Okay, now what we are going to do, as I said that I will be taking this full pack of one single paper in a batch of 2 or 3 session so that you understand and you also get to know the concepts involved. So let us not hurry up and finish this up clearly. Okay, so that's the point. Now that ends the lecture now for today. Okay, and I want you to, if you like, okay, subscribe to it, and that's the way you have to go about it. Okay, so thank you very much, children. God bless you all. I catch you up in the next session, might be day after tomorrow, okay, on I think Thursday, same time, 8:15 to 9:15. Okay, we will continue with the 4 marks question and then we will say bye bye for that. Okay, so thank you very much for being with me. God bless you all. Remember, this is an open class, so anybody can come. Anybody who have other occupation, they can go ahead with that. But you can just spread so that the ISC students of any school benefit from this particular class. So thank you very much. God bless you all.